going on, guys? Let's look at this problem right here. Here this question is asking a positive sequence balanced three-phase Y connected source with a phase voltage of 120 VRMS supplies power to a balanced Y connected load. The per phase load impedance is 40 plus J10 ohm. Determine the line currents in the circuit if V is equal to the angle V is equal to 0 degree. Okay, now let's go ahead and draw the Y system, Y circuit, because all of them are given in three-phase Y connected source. So we are going to draw the Y circuit. Y circuit is going to look like this. Okay, and here we have resistance, impedance, resistance connected with this okay. Here we have the voltage source provided, that is 120 voltage VRMS, 120 voltage, and the angle is given to be 0, so 0 degree. And also we have the impedance provided 40 ohm, and the imaginary part is J10. Now here the question is asking for the load current. Now the easiest way is you can just connect this one alone. You can take this part alone and make a circuit around that. So if we take a circuit, it's a simple circuit, 120 angle 0, and the impedance is 40 J10, connected like this. And we know that V is equal to IZ. Since we are trying to find line current, this is LA because the top part is A. So I line current A is going to be V divided by the impedance. V is 120 angle 0. 120 angle 0 divided by the impedance, that is 40 plus J10, and that gives us 2.91. Angle is negative 14 degree ampere. Okay, this is the current through this one, ILA. Now we have to find out ILB and ILC as well. ILB, and this one is ILC. The only difference is they vary by 120 degrees. Now if you take ILB, for this one you have to just subtract 120 from this. 2.91 minus 14 minus 120, that's going to be minus 134 degree ampere, and ILC is going to be 2.91, and if you add negative 14 degree, that's going to be just 106 degree ampere. Okay, now we calculated ILB and ILC. Now the next thing is total three-phase power absorbed. That's going to be P power 3/5, and that's going to be 3 times 3 times the real part of the resistance, that's 40, times the IRMS resistance, IRMS current, that is 2.91 square, and that gives us 1016 watts, and total reactive power, that is Q power 3/5, and that gives us 3 times the imaginary part is, that is 10, times the IRMS current, that's 2.91 square, and that gives us 254 voltage ampere VAR. Okay, now this is total reactive power, and also you can find out the total power delivered by the source. Total power delivered by the source to the 3-5 system, that is coming from here, this source, and to calculate that one, that is 3 times 120, because that's the voltage right here, 120 times the phase current with the angle, that's going to be 2.91, but the angle, we only have to change the angle to be positive, so this is going to be just plus 14 degree. And if you calculate this one, that's going to be 1016, and the imaginary part is going to be J 2.54 voltage ampere. Okay, now we can also find out the three-phase power absorbed using a different formula. P power 3 phi is going to be equal to root 3 VL IL cos phi. Root 3 V load is root 3 V phi. V load is equal to root 3 V phi root 3 times V. The given voltage is 120, and if you calculate the voltage, that's going to be just 208. So 208 multiplied by the load current, that's going to be 2.91 times cos, and if we make the angle for this theta, and angle for the impedance, y-axis is going to be the imaginary part, x-axis is going to be the real part, 40. So this is going to be tan inverse. Tan is opposite over adjacent, that's 10 over 40. And if you calculate this one, that's going to be 1016 watts. And that's another way to calculate this total three-phase power absorbed. This is similar to this one. Okay, this is shorter method. This is longer method. This is longer method. And this is total reactive power. And this one is the total three-phase power delivered by the source. And that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electromechanical system, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.